Now let us study the characteristics of the cotangent function. So as you can see, there we have a graph on screen, okay, illustrating the cotangent function. Let's start by identifying the domain of the given function. So as you can see, just like the tangent function, there are vertical asymptotes. So let's start here. Okay. Then another here. And here. So you can see that the asymptotes are found at the points having abscissa 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. So therefore, the domain would be the set of all x such that x is not equal to n pi, where n is an element of the set of integers. Okay, just like the tangent function, the range is the set of all y such that y is an element of the set of real numbers. The amplitude is also not defined since the highest value and the lowest value of the function cannot be determined. Now for the period, let's see, from 0, we can get a complete cycle from 0 to pi. Therefore, the period of the cotangent function is pi. Okay, in the interval 0 to pi, there is one complete cycle, so the frequency in this interval is 1. The cotangent function is given by f of x equals b plus a times cotangent of c of x plus d, where c is the frequency, b as the vertical shift, and d as the horizontal shift. The change in the value of a here implies the vertical stretch of the graph of the function cotangent. Now let us discover the effects of changing the values of the variables a, b, c, and d. Now let's start with the change in the value of a. So let's say we have g of x described by 2 cotangent x. Now let's compare that to the graph of f of x described by cotangent x. Okay, remember that the domain of f of x is the set of all x such that x is not equal to n pi, where n is an element of the set of integers. For g of x, do we have the same domain? Yes, because the vertical asymptote did not change, so there is no significant change in the domain. The range is still the set of all y such that y is an element of the set of real numbers. Okay. The period is the same. Okay. Now, in other words, changing the value of a in a cotangent function will not give a very significant effect on the domain and range, including the period. But we can just describe generally that the graph seems to be stretched away from the x-axis. Okay, that is if the value of a has changed from 1 to positive infinity. If it's negative, the graph will just be reflected. Okay, so let's proceed. What if there is a change in the value of b? So let's say we have 2 plus cotangent x. Okay, it seems that the graph of cotangent x is translated upward. How many units? Let's see. If we get this point, okay, y is 0. Okay. Now, if we get exactly the point above point A, we will have point B having a y-coordinate of 2, which indicates that the movement is upward 2 units. Okay, that's the effect of having a change in the value of B. Now, what about if the value of B is negative? Then we can have, okay, what if B is equal to -2? Now take a look. Okay, this point, okay, if we take this point, we have y equals 0. Now in this point, we have y is -2. So it shows clearly that if the value of B is negative, the graph is shifted downward. So for in this function, -2 plus cotangent x, the graph of cotangent x is vertically shifted 2 units downward. Now, what if we change the value of c? From 1, we have 2. So from cotangent x, we have cotangent 2x. If we will have cotangent x, remember that the domain is the set of all x's such that x is not equal to n pi, where n is an element of the set of integers. What about for the g of x? What will be the domain? Now, take a look. We have here a change in the vertical asymptote, okay? Then another here, okay, and here. So it seems like in the interval 0 to pi, there is 2 complete cycles. So the frequency is 2. Now we determine here this point. So this is pi over 2. Okay. So this is 0, pi over 2. Then we will have pi, but this can be expressed as 2 pi over 2. Okay, so that we can see clearly the pattern. Okay, now here we have 3/2 pi. Okay, then here we have 4 pi over 2. So looking at these numbers, these are multiples of pi over 2. So that is the significant change in the domain. That is the significant change in the domain. Right now, the domain, the set of all x's such that x is not equal to n pi over 2, where n is an element of the set of integers. Okay, so that's the change in the domain. What about the range? The range is still the set of all y such that y is an element of the set of real numbers. No significant change in the range. What about the period? Okay. For the period, as you can see, we have 2 complete cycles in the interval 0 to pi. Therefore, in g of x, we will have pi over 2 as the period. Okay, there is no vertical shift or horizontal shift yet. Okay, so that means that changing the value of c will also affect the domain and the period of the function. Okay, now let's have a change in the value of d. So what if we will have x plus, let's say 3. Okay, So we also change the units. Now, if we have x plus 3, what will happen to the graph? Okay, so if this will be 1.5, let's get a point on this. Okay, so this is negative 1.5. Here, 1.5. Okay. It's like a movement to the left 3 units. So if you get the difference of 1.5 and negative 1.5, or it will give us 3 units. So therefore, the change in the value of d tells us a horizontal shift. In this case, the graph of cotangent x is shifted to the left 3 units. Okay, these are the transformation in the graph of cotangent x as we change the value of the variables a, b, c, and d.